Hi, I'm Molly with the Coastal Watershed Council, and welcome to our activity guide, Nature's Water Filters. Our guiding question for today is, how can nature be used to protect nature? During this activity, you will observe what happens when it rains on different surfaces. You'll learn about the differences between permeable and impermeable materials, and you'll build your own water filter using just sand, soil, and pebbles. For this activity, you will need sponge, pencil, water, a plastic bottle, soil, rocks, sand, that's optional, cotton balls, and a piece of cloth. We also have printouts or activity guides you can follow along with. You can find these on the Coastal Watershed Council website, or your teacher may have shared these with you. It looks like this.
Hey everyone, it's me Sam from the Coastal Watershed Council. And today we're going to be looking at permeable and impermeable surfaces. And what that means is, when you pour water on something, does that something absorb the water, or does the water just slide off? All we needed to use for this study is a sponge and a cup full of water. The idea is that we're going to get the sponge wet in the water, and then we're just going to make it rain by squeezing the sponge onto different surfaces to watch what happens. Let's start by investigating what happens when we squeeze water on rocks. Will the rocks absorb the water, or will the water slide right off? What do you notice is happening?
Thanks, Sam. What did you notice happening to the water? Sam modeled our activity for us. Let's take a review of the different steps you're going to take. You're going to find a sponge and a cup of water, and then ask permission to go to your yard or along the sidewalk in your neighborhood. And then you're going to make it rain. Dip the sponge in water and squeeze the sponge on each surface. You're going to see that on the next slide. And then watch and observe what happens to the water. Sam modeled testing the rocks and observing what happens when we make it rain on rocks. And you're going to do the same. You're going to test cement, grass, rocks, and soil. And for each of those, record what you notice happening. Does the water sink in? Does the water stay on top? Or does the water flow away? You can write your notes on a blank piece of paper, or print out the activity PDF and you can use this as a checklist. If you're ready to go outside, go ahead and pause the video and do those tests to see what happens when you make it rain on the 4 different surfaces. If it's easier for you to stay inside, that's okay. Sam's going to do the experiment for us and you can observe what happens to the water.
And now we're going to investigate what happens when we squeeze water from our sponge onto a surface like cement that's man-made. Is it going to sink in? Is it going to roll right off? Looks like for this one, the answer is a little bit easier. Soaking in or sliding off? What do you see happening with the water? Our next thing that we're going to investigate is a natural surface, something that has plants growing just like grass. So again, is the water going to be absorbed, but the water just gonna slide right off. Let's check it out. Is the water pooling up? Is it soaking right in? Or is it sliding off the top of the grass? I can make it rain one more time so you can look up close. What do you see happening? Now we're gonna test the soil. I wonder if the soil is going to absorb water or if the water is gonna slide right off the top of the soil. What do you think is gonna happen? Sometimes it takes a minute for us to realize what's going on with the water. Is it sinking in? Is it pooling up? Or is it gonna slide away?
Thanks, Sam. So now let's take some time to write down what we noticed when we made it rain on cement, grass, rocks, and soil. Take some time to write down what you noticed. You can draw a picture of what you noticed as well, and then come on back when you're ready. You probably noticed that when you made it rain on grass, that the water moved through it, right? That the water moved through the individual blades of grass. And probably the same way that when you put water in a sponge, the water goes through the sponge, and if you squeeze the sponge, the water comes out, right? So a permeable surface is a surface or a material water can move through, just like a sponge or grass. Oppositely, you probably saw that when we made it rain on cement, the water couldn't go through. Or if we're holding an umbrella and it's raining, the umbrella keeps the rain from hitting us. Both cement and an umbrella are impermeable, and that's a surface or material that water cannot move through. Now it's your turn to decide whether the surfaces you tested are permeable or impermeable. So either on your blank piece of paper, or if you have printed out the activity guide, check off whether the cement, grass, rocks, and soil are permeable or impermeable. Go ahead and pause this video, answer the questions, and then come back when you're done. Awesome. Here's the answers. So cement, it's impermeable. Grass is permeable. Rocks are permeable. And soil is permeable. It's great to know that grass and rocks and soil are permeable. But why does that really matter? One of the reasons it matters is that permeable materials help sink water into the ground. When we made it rain on the rocks, the soil, and the grass, we noticed that water sank into the ground. That's good news. We want the water to get into the ground. We can use that water later on to take showers or as drinking water. It also helps stop all the extra water from going into storm drains. And secondly, permeable materials trap pollution. Pollution are things that are hurtful to the environment, like trash, dog poop, and car oil. We don't want the pollution going into the river or ocean. Permeable materials like pebbles, soil, and grass can actually trap pollution in between its little pieces. So the permeable materials stop pollution from entering our rivers and ocean. Great news. Let's take a mind break. Everyone stand up and stretch or shake it out. Here we go. Awesome. Welcome back. So our next activity is to build a water filter using permeable materials like rocks. Here's Sam again. He's going to show you the steps to building your water filter.
Instructions. First thing we need to do is gather our materials. You need an old water bottle that you cut in half. We're going to be using both of these pieces, but we don't really need the lid, so I'm going to leave that aside. And eventually we're going to be fitting this top part into the bottom half. We also need some cotton balls or pieces of fabric. I've just cut up an old t-shirt that I had laying around and never gets used. That way we can reuse these, so if you have cotton balls, that works great too. We have a little bit of soil. You can get this from a pot of soil if you have some, or under a tree, or at your park. I've also got some sand here, some small rocks, and some water. This could be a cup of water, this could be a bowl of water, anything that you can have some water, because we're going to be adding some of the soil to our water to make it really dirty.
Thanks, Sam. Go ahead and pause the video so you can gather all these materials, and then come back when you're ready.
The goal of this activity is to see if we can use just these earth materials that are easily available to make dirty water into clean water. We're not making this so we can drink the water, but we're using this to see how the water, dirty water, might interact with the different types of earth materials to clean it up. So the way we get to do this is by taking the top half of the water bottle with the spout, holding it upside down, and adding your cotton balls or your pieces of cotton fabric to the bottom. That way no chunks fall out the top. We then are going to add a bunch of sand. You can fill this about halfway up with sand. That should be good. And we'll add a layer of rocks on top of that. When we pour our dirty water in through this filter that we've just made, I wonder if the water is going to be any cleaner coming out the other side. I'm going to fix these two together just by twisting them around, and I'll set this aside.
Thanks, Sam. Go ahead and take those steps that Sam just shared with us, and then come on back when you're ready for the next step.
It's time for us to make our dirty water before we do this experiment. So I've got my clean water, and I'm just going to add a couple pinches of dirt to this water. Might get a little messy. You could do this outside, or make sure you have a table mat so you don't get your table super gross. So I've added some soil to make this water really muddy. Something like this might happen in nature if there is a landslide, or something called erosion, which is when the banks of the river start to get washed away. Give it a couple shakes. This water sure is dirty. Now let's see what happens when we pour it into our homemade water filter. I'm seeing it slowly drain to the very bottom. It might take a minute or so, but you can see the water level, how it's going down. We're about to the sand now. The rocks look like they have captured a lot of the big chunks, and some of the smaller chunks are probably getting caught by the sand as well.
Even though the water that's coming out of our water filter isn't perfectly clear, if we compare these two, my question for you is, do you think our water filter worked?
Ooh, let's find out if your water filter works. Go ahead, pause the video, take those steps that Sam just shared with us, and then come on back so we can review the results.
After we've completed our experiment, seeing that we've been able to put the dirty water through our filter, which is still dripping water, but it's not as dirty, I have some questions that we can reflect upon. What worked best about your water filter? Is there something that you thought was maybe the best material to use? What would you change for next time? Maybe you would add more rocks, add more sand, maybe the cotton balls do you think is the best part of this filter? And why do you think we can use sand, pebbles, and dirt to help protect our rivers?
Thanks, Sam. So take some time to write down your thoughts to each of these questions or share them with someone that's nearby. So again, it's what worked about your water filter? What would you change for next time? And why do you think we can use sand, pebbles, and dirt to help protect our rivers? That's it for today's activity. Remember, you can make a difference. You make a difference, and your actions matter. How can you use what you learned today to help out our community and nature? It was fun to explore with you today. You can find other activities at the Coastal Watershed Council website at coastal-watershed.org. And if you have any questions, you can email me at mbain@coastal-watershed.org. Thanks everyone. Have a great day.